session, we will be looking at how to solve a pair of simultaneous equations using a matrix method. Consider the pair of simultaneous equations. Now, our first step in using a matrix method to solve this pair of simultaneous equation is to extract the coefficients of your variables. And our variables here are x and y, so our coefficients will be +3, +2, +1, and 4. So we will take those coefficients and we are going to put them into a matrix. And we are going to keep the form or the order that those coefficients appeared. So I see 3 on top here, that is where I wrote it there. I see 2 here, I put 2 there. I have 1 understood to be here, I write 1 underneath that 3, and 4 goes underneath my 2. Right? So here I have my matrix and I'm going to call that matrix matrix A. Now our variables go into a separate matrix, and our variables here, we understand our variables to be x and y, and I'm going to call this matrix X. Now our results are going to go into another matrix, and I'm going to call that matrix matrix B. So here we have AX is equal to B. Now what we have written here is simply a different format of writing this pair of simultaneous equation here, because I'm seeing that matrix A, when I multiply matrix A by matrix X, I'm actually going to get back what I see on this side. Remember, when you multiply matrices, you use the row by column technique. So you're going to get 3 multiplied by x, that is going to give me 3x, and then you are going to add 2 multiplied by y. So you see how you get back 3x plus 2y. And that answer is actually going to go here, and we are seeing that the answer here is 8. So now you are seeing how you can take a simultaneous equation and use a matrix method to represent it. So now what we are going to do is we are going to solve our simultaneous equation using that matrix method. So I have A multiplied by X is going to give me B. And we have our unknowns or our variables being represented by the matrix X. So if, for example, you have 3 multiplied by some unknown and you get, let's say, 9, how am I going to figure out that unknown? Yes, we simply divide 9 by 3. So we take what is here and we divide it by this element or term here. So what we need to do is take B and divide by A. But wait, we don't have division in matrices. What we have that is used to represent division is the inverse. So the same as dividing B by A, what we will do is take A inverse and multiply that by B. Right? So now we need to figure out what A inverse is. A inverse is 1 over your determinant of A multiplied by your adjoint. Your determinant of A is AD minus BC. This here is our matrix A, so we are going to label it A, B, C, D. And what we are going to do is plug in those values here. So we see A is 3, D is 4, so I get 3 by 4. Take away 2 by 1. So it's 2 by 1. And what we are going to get there is, that's 12, take away 2, and I'm going to get 10. So we are seeing that our determinant is 10. Let's work out for our adjoint. Our adjoint is going to be where we switch D and A and we change our signs of B and C. So I'm seeing that A is 3 and D is 4, so I'm going to switch these two. So you are going to get here as 4 and here as 3. And I'm going to switch or change the signs, I'm going to change the signs of my B and C. So I'm going to get -2 and -1. So now we have our determinant as well as our adjoint. Let's plug it in and work out what our A inverse is. So we write here, A inverse is going to be 1 over our determinant, which is 10. Remember, it's 1 over your determinant. So it's going to be 1 over 10 multiplied by your adjoint, which we just worked as this. So let's simplify it. 1/10 multiplied by each one of those elements. We're going to get 4 over 10, -2 over 10, -1 over 10, and 3 over 10. Now that we have our inverse, remember, we are solving for each one of these variables, and in order to solve for that, we are multiplying the inverse by the matrix B. So we will write here, A inverse by B is going to be 4 over 10, -2 over 10, -1 over 10, and 3 over 10, multiplied by B, and we are seeing B as 8, 6. So we are going to do our normal row by column technique to multiply this, and we are going to get 4 over 10 multiplied by 8 plus -2 over 10 multiplied by 6. Here, now I'm on to my second row, so it's second row by that column there. So it's -1 over 10 multiplied by 8 plus 3 over 10 multiplied by 6. So what we need to do now is simplify those stuff and work them out, and we will get our answer. Okay, so I have worked that out there for you, simplified and performed my operations, and I have gotten 2 and 1. So what this means is that x, let me just go back. Remember, our matrix X was XY. So X would be 2 and Y would be 1. So that's our answer there. We are going to write X equals 2 and Y equals 1. So what we can do is just double check to make sure that that value or those values actually work out. So let's see. We are going to substitute X as 2 and Y as 1. So we're going to get 3 multiplied by 2, that's 6. And 2 by 1 is 2. So 6 plus 2 is 8. So yes, that first one there, it works out for that. And let's make sure it holds true for our second equation. X is 2, so that's 2 plus 4 by 1, that's 4. 4 plus 2 is 6. So yes, X is 2 and Y is 1.
Don't forget to like, share and subscribe for more of my videos.